Hi, I'm Orlandi and I'm pleased to show you my work, which is about the change detection technique in order to support the InSAR surface deformation analysis, and especially on the Etna volcano activity in 2021. So, Etna, as you will know, is one of the most, actually it's the most active volcano in Europe. And since the last December this year, the activity increased a lot, especially with several paroxysm phenomena. So, I took the 16 February event where there was a lot of emissions and ash emissions and also lava fontaining. From this event, the volcanic activity increased even more. So, all this caused also a lot of damages on the buildings, on the fields, and also a lot of ashes on the roofs, on the streets, so many damages. So, let's say that InSAR is a technique that it's worldwide known to be one of the most important to monitor the surface deformation. But it's not only this, because it's been also useful to change detection and also to see the change of the coherence in time. So the object of this work is to take advantage of this potential in order to exploit the change of coherence in time, seeing the change of the coherence before and after this important event of 16 February 2021. So what I did was basically choosing 6 days interferograms with 5 acquisitions. So basically doing 4 interferograms, and the processing I wrote like co-registration, interferogram formation, the burst, topography removal, multi-look and Goldstein filter are the same that I used for the interferometry, except the unwrapping phase. So as you can see here, there are 2 examples of the coherence map, and we have the event, which is the dashed line orange, and we see the before and after coherence map, where we have the coherence that goes from 0 to 1, where we have 0 that is black and it's really not, it's really decorrelated, where we have 1 which is white and it's really high correlated. So what I did basically was calculating the ratio, and obviously also for a better visualization, the logarithm 10 base 10 of the ratio. So here are my results that I show with the legends. There are that goes from below 1. It means a coherence increase, and above 1 it means a huge coherence decrease. More or less this is the same for the log, but except that the limit is 0, that below 0 is a coherence increase and above 0 is a coherence decrease. So as you can see, the more we go ahead with time, the more we have very changes with the coherence on the surface. So, for example, in the crater, in the center area, we have a lot of decrease of the coherence, and progressively, as we go to the slopes around the crater, we have an increase, a huge increase of the coherence, both in the ratio and in the logs. Here, I report an example that we have in the slope in the northeastern part. Especially, we see a complete change of the surface of the coherence, going from a part which is decorrelated, passing to a part which is a really high coherence increase. So my conclusions are obviously that InSAR is a good way either to study deformations and obviously to monitor the surface deformation, but also to exploit the changed surface, the change of the coherence on the surface. The event of 16 February caused several damages, but the thing is that more studies require deeper analysis, especially in order to be able to discriminate the presence of snow or lava that are along the slopes. Thank you very much for your attention.